Hi guys, this is Monica, and today I'm going to be going over number 48 from chapter 19. The problem states a typical nuclear reactor generates 1,000 megawatts of electrical energy. In doing so, it produces 2,000 megawatts of waste heat that must be removed from the reactor to keep it from melting down. Many reactors are sited next to large bodies of water so that they can use the water for cooling. Consider a reactor where the intake water is 18 degrees Celsius. State regulations limit the temperature of output water to 30 degrees Celsius so as to not harm aquatic organisms. How many liters of cooling water have to be pumped through the reactor each minute? So here I drew a small illustration of a nuclear reactor, which in real life is much more complicated. But basically, we have the nuclear generator, and here we have the cooling tower. So we have some sort of reservoir off to the side, and water is being pumped in at 18 degrees Celsius, and it's being pumped out at no more than 30 degrees Celsius. So to solve for this problem, the question is how much water is needed to cool down the power that is wasted, which is 2,000 megawatts. This value is basically our Q given per second. So Q is 2,000 megajoules per second. The first step to solve this problem would be to find our mass every second, and we are using the formula Q equals mc times delta T, where m is the mass and c is the specific constant for water at a specific temperature, and delta T is our change in temperature. So in this case, m is Q over C delta T. Our Q is a 2,000 times 10 to the 6 joules per second, so converting the megajoules. And our C in this case is 4,186 joules per kilogram times degrees Celsius. And in this case, we're not converting to Kelvin because we want to make sure that our units cancel out. So 30 minus 18 degrees Celsius. And we should get 39,815.257 kilograms per second. Now the second part is finding out how many liters are pumped out every minute. So we know that 1 minute is 60 seconds, so we simply take our initial value found from part A and we multiply that by 60 to get that at every minute. This is the amount of water that is being pumped out. And now we're using its density. We want to convert it to liters per minute. So we know that the density of water is 1,000 kilograms per meters cubed. And every meter cubed has 1,000 liters in it. So essentially the density is 1 kilogram per liter. So now we just simply convert our value found, and we arrive to the conclusion that per minute there is 2.4 times 10 to the 6 liters of water being pumped out through the reactor.